19th century England, Scotland and Wales, collectively known as Britain, with the Industrial Revolution in full swing. It was a time when men, women and children worked 12 to 14 hours a day deep underground, extracting a very precious black substance. Coal. It was because of coal that Britain was able to power newly invented steam engines and father an industrial revolution that would change the world. Meanwhile, on the other side of the Atlantic, a Colonel Edward Drake built the first oil well in Pennsylvania in 1859 and started refining oil. Initially it was used to power kerosene lamps, which came to replace whale oil lamps, something for which whales could be forever thankful. Later oil, in the form of petroleum, was used to power transport vehicles such as cars, ships, trains and planes, and for domestic and commercial heating. While another product used in the extraction process, natural gas, also became an invaluable heating source. The other game changer that pretty much set the stage for modern civilization was the development of large-scale electricity generation. Thomas Edison got the ball rolling with his direct current or DC electricity, but it was the alternating current or AC electricity supply system designed by Nikola Tesla that was to prove the game changer. In 1893, Tesla's AC electricity lit up the Chicago World's Fair, and in 1895 he was to famously generate AC electricity by harnessing the power of Niagara Falls and creating the world's first hydroelectric power plant. It was, however, coal that was to become the major player in electricity generation for years to come. While we didn't really know it at the time, coal, oil and gas, known as fossil fuels, because they are the products of plant and animal fossils buried deep in the ground, would open the door to what might truly become a real horror show. The problem with carbon dioxide and other gases such as methane, water vapour, ozone and nitrous oxide is that they form a layer in the atmosphere that prevents shortwave radiation that reaches the Earth from the Sun being returned back into space as infrared radiation. This is known as the greenhouse effect, as the same principles are at work in a garden greenhouse. It's a little bit like covering the Earth with a blanket, causing the Earth's temperature to rise. The burning of fossil fuels to provide energy to power the world has produced vast amounts of greenhouse gases, primarily carbon dioxide, which have caused Earth to warm considerably since early industrial times, especially since the early 1900s. Furthermore, we have emitted more carbon dioxide in this short time than there has been in any time stretching back over hundreds of thousands of years, and this carbon dioxide itself will remain in the atmosphere for thousands of years to come. There's also a close correlation between carbon dioxide levels and global temperature rise. But the production of greenhouse gases has not been confined to the power and transport industries. An area that has contributed significantly has been animal agriculture for meat, especially with regard to ruminant animals, such as cows and sheep, which release methane into the atmosphere when they burp and fart. Fertilizers, which are used to grow animal food, produce another greenhouse gas, nitrous oxide. The majority of all agricultural activity goes into the production of foods for animals that are raised for human consumption. There's also a huge deforestation to provide grazing land for meat-producing animals. Forests are major carbon sinks, which, like the oceans, have the ability to absorb and store carbon dioxide from the atmosphere. Industry too is a large greenhouse gas producer. Concrete and iron and steel, for example, require massive fossil fuel heat in their production. A drastic increase in carbon dioxide emissions occurred following World War II as part of what is now referred to as the Great Acceleration, so called because there was a major increase not only in carbon dioxide and other greenhouse gases, but also population, economic activity, water usage, food production, transportation, surface temperature, and natural resource usage. This man-made acceleration has been so pronounced that it is now recognised that we have truly established a new geological time or epoch called the Anthropocene, a time beginning at the start of the Industrial Revolution until the present. Some 97% of peer-reviewed journal papers show that scientists accept overwhelmingly that greenhouse gases in the atmosphere cause rising temperatures, although there appears to be a temperature lag, with the median time between carbon dioxide emission and maximum warming of about 10.1 years, with a 90% probability range of 6.6 to 30.7 years. This means we're experiencing the results of carbon dioxide levels from the early part of this century or the latter part of the last. In 1988, climate scientist James Hansen, appearing before a US Senate committee, was the first to warn government of the impending consequences if fossil fuel-induced global warming continued unabated. But his message for the most part fell on deaf ears, and in many circles he was openly ridiculed. His projections at the time have proved to be very accurate, however, if a little low. In the years that followed, while the scientific community almost unanimously supported Hansen's assertions that man-made or anthropogenic climate change was real, with greenhouse gases being responsible for a continuing rise in global temperature, political opinion generally has failed to either understand the enormity of the problem or accept the reality that climate change is actually occurring. What was considered a major breakthrough came in 2015 at the Paris Climate Conference, when 196 participating countries agreed to reduce their carbon output to keep global warming in a range of 1.5 to 2 degrees Celsius and made non-binding pledges to do so. Countries such as the Philippines, however, with islands threatened by rising sea levels, argued that the target should be no more than 1.5 degrees Celsius and ideally no more than 1 degree. It is important to understand that 2 degrees Celsius is not a number that is a scientific cutting point under which global warming can necessarily be contained. It is more of a political temperature that representatives of their respective governments have agreed upon in terms of what their countries are willing to commit to. Even 1 degree Celsius increase is considered by many in the scientific community to be too high. In the ensuing years, however, countries have failed to make good on their pledges, with only India, Ethiopia and the Philippines among the larger countries still on track to fulfill their pledges. Indeed, under the presidency of Donald Trump, the United States of America, one of the world's largest emitters of greenhouse gases, has actually withdrawn from the agreement. The same President Trump was quoted as saying that climate change was a hoax perpetrated by the Chinese to make the US less competitive. It is true to say that climate change cannot be divorced from politics and political will. While many politicians do not accept the reality of climate change, others are reluctant to do anything about it because it would affect the cost of energy, which is always a major concern among voters. Politicians are generally more concerned about short-term consequences than what might happen years beyond their immediate electoral cycle. They're always very reluctant to tackle issues that may affect their re-election prospects. Furthermore, the fossil fuel industry in the US, through people like the Koch brothers, are major contributors to political campaigns, so congressmen are often very reluctant to act against the interests of their major donors. We have to remember too that all of us in the developed world are locked into a fossil fuel lifestyle. There is very little in our way of life that does not involve some aspects of fossil fuels. There are literally thousands of things we use every day that use petroleum in their manufacture, including all plastics. By way of example, to produce one disposable plastic water bottle takes the equivalent of filling that bottle with a quarter of its volume with oil. The USA alone uses about 50 billion plastic water bottles annually, which requires about 17 million barrels of oil a year. The demand for energy is only going to increase with the need for constant productive economic growth to maintain a functioning economic system, and a rising world population, and the still billions who have no electricity, but like the rest of us, want it. There is currently a push for renewable energy growth in the form of wind and solar energy. However, together they provide less than 10% of the world's energy and do not have the capacity in the foreseeable future to replace the energy currently provided by fossil fuels. Even if we include hydroelectric power, the amount of energy required falls far short, with some 75 to 80% of renewable energy required to make up the gap. This is made all the more difficult with the phasing out of nuclear energy in places such as Germany and California, even though nuclear does not produce greenhouse gases. And the fact that there is no practical form of carbon capture, where carbon dioxide and methane emissions can be stored underground, which the IPCC considers essential if we are to keep the global temperature below 2 degrees Celsius. So despite all the pledges, smiles and handshakes among the Paris Climate Conference IPCC delegates, the world is on track, according to the Independent Climate Action Tracker, which monitors individual country IPCC pledges, to see an increase of 3.4 degrees Celsius with a 97% probability of exceeding 2 degrees Celsius by 2100, and in all likelihood, with business as usual, much sooner. Today the concentration level of carbon dioxide is at 410 parts per million and is exponentially rising. Ice core samples tell us that this is much higher than any of the geological epochs in the past 400,000 years, when carbon dioxide concentration reached a maximum of about 300 parts per million. Before the Industrial Revolution, it was no more than 280 parts per million. The annual mean global land-ocean temperature index shows that there has been a rise in temperature of 1.4 degrees Celsius between the early 1900s and 2017. In May 2018, the land and ocean temperature was 0.8 degrees Celsius, with the ocean at 0.66 degrees. Since there is more land in the northern hemisphere, the temperature is higher than in the southern hemisphere. On current trends, with business as usual, 2 degrees warming could very well occur in the 2030s. Preventing such a scenario will largely depend upon curbing increasing carbon dioxide output from the economic sectors and whether we are able to develop a means of extracting the carbon dioxide already in the atmosphere by some form of geoengineering. While current weather events such as prolonged heat waves and droughts, wildfires and serious flooding are increasingly alarming, we must remember that these events are the likely consequence of carbon dioxide emitted into the atmosphere decades ago. The results of what we are currently producing may not appear for decades to come. Who knows exactly how much the global temperature will rise and exactly what effect it will have on the planet and all that inhabit it. What we do know is that the planet is comprised of a myriad number of interconnected systems, and that events are very unlikely to happen in isolation. Feedbacks and tipping points are likely to occur, and in all probability, given that events in geological time are happening at such a rapid pace, that they'll be very hard to control. So what are these possible feedbacks and tipping points that may already be in play? Let's start with the Arctic, which is perhaps the most observable region in which climate change is causing alarming changes. While most of the regions across the globe have experienced temperature rises of less than 1 degree Celsius, the Arctic has risen 2 degrees. This has had the effect of melting 3/4 of the sea ice in less than 30 years. We are fast approaching a time, possibly in as little as a couple of years, when there will be an ice-free Arctic in September. Not too long after that, there will be an ice-free Arctic for 3 or 4 months a year. An ice-free Arctic would lose its reflective or albedo capacity. Being white, ice reflects 90% of the sun's energy back into space. Were the ice to go, 94% of the sun's energy would be absorbed by the ocean, thereby increasing the ocean's rate of warming. One of the great fears is that up to 50 gigatons of methane, contained in the Arctic shallows less than 50 metres deep, could be released in vast amounts from the permafrost in the ocean floor, potentially causing a global temperature rise of as much as 0.6 of a degree Celsius. Methane, although it does not remain in the atmosphere for more than about 30 years, is as much as 100 times more potent than carbon dioxide in the first 5 years of its release. With the disappearance of sea ice leading to a warmer ocean, there will be sea level rise, since warmer water occupies more space than cooler water. Rising ocean temperatures are also accompanied by rising atmospheric water vapour, which, like carbon dioxide and methane, is also a powerful greenhouse gas. Water vapour also provides fuel for hurricanes, which are likely to increase in intensity. Greenland too is losing much of its land ice very steadily, and this could cause substantial sea level rise as temperatures increase. 3 million years ago, when the temperatures last reached 2.3 degrees Celsius range, there was no Greenland ice and sea levels were 25 metres higher than they are today. This sea level rise may take many decades or even centuries to occur, but once the melting starts, it is not scientifically possible at this stage to prevent it. The melting of Greenland land ice and Arctic sea ice also has the potential to slow down the thermohaline circulation in the North Atlantic, thereby affecting the global ocean conveyor belt, which circulates cold, salty, deep water from the North Atlantic to the Pacific where it then returns warm, shallow water back to the North Atlantic. Such a slowing down could cause substantial cooling in eastern North America and western Europe. It is also estimated that 24% of the northern hemisphere in the boreal forest and tundra regions is comprised of permafrost, which acts as a cap on vast amounts of methane stored underneath. Unfortunately, this permafrost is already thawing, and were it to be fully released, it would more than double the amount of carbon dioxide already in the atmosphere. The rising temperature in the Arctic has also seen a disruption of the polar jet stream. The jet stream is fracturing in parts and also moving more slowly from west to east. Just like a slow-moving, meandering river, the jet stream is displaying large bends or peaks and troughs, and acting like a curtain containing cold air from the Arctic in the troughs and warm tropical air in the peaks. On the one hand, we are seeing record prolonged temperatures with wildfires extending into the far north of the planet, and on the other hand, prolonged freezes extending much further south than would normally be expected. The melting of land ice and glaciers is not confined to the northern hemisphere. Antarctica in the southern hemisphere is also experiencing large-scale land ice loss, especially in the West Antarctic, where ice sheets and glaciers are exposed to warmer sea temperatures. Between 2012 and 2017, Antarctic ice melt has tripled. Ice melt in the Antarctic, Greenland and the mountain glaciers could result in rapid sea rise this century, threatening many of the world's major coastal cities, river deltas, low-lying islands and countries where hundreds of millions of people live. China, especially Shanghai, India, Bangladesh, Vietnam, the Netherlands, Florida, the Maldives and numerous Pacific islands are just a few of the regions which would experience major flooding due to sea level rise with 3 degrees warming, the current temperature rise predicted by the IPCC if we continue with business as usual. There is also the likelihood that storms and hurricanes would increase in intensity due to increased moisture in the atmosphere, which would cause heavy rain, storm surges and flooding, and only exacerbate the problem. Sea rise is not the only consequence of global warming for the oceans. Oceans are also great carbon sinks, which absorb about 25% of human-created emissions. But with increased ocean temperature, this capacity is reduced. Ocean acidification is another problem created by ocean warming. Normally the oceans are alkaline, but with the extra absorption of carbon dioxide, carbonic acid is produced. The pH balance changes and the oceans become more acidic. This can cause the calcium carbonate shells of sea creatures to break apart. There is also a fear that because of ocean acidification that we will lose much, if not most, of the ocean's plankton, the very basis of the ocean's food cycle. Coral reefs are also under great stress due to warming seas, with over 60% of the Great Barrier Reef under threat through bleaching and the possibility of eventual destruction. Were coral reefs to go, as much as a third of all marine life would disappear, since the reefs are an integral part of marine life cycles. At the extreme end, if the temperature was to increase by 5 to 6 degrees, which is a distinct possibility before the end of the century, there is a chance that hydrogen sulfide gas, produced in the ocean through sulfate decomposition by sulfur bacteria, could be released, killing life in both the oceans and on land. It has been proposed that hydrogen sulfide gas may have been responsible for the Permian mass extinction 252 million years ago, although this is a matter of some dispute. Back on land, an increase of 2 degrees warming could have devastating consequences for tropical rainforests. It is estimated the Amazon rainforest could experience 40% dieback, which would release massive amounts of carbon dioxide back into the atmosphere. A major fear is that global warming will cause prolonged droughts in the major food production areas where grains and staples are grown for both human and meat-producing animal consumption. It is also estimated that for every degree of warming there is a 10% decline in crop yields. Already droughts in the Middle East and Africa are responsible for thousands of refugees fleeing their homelands, and this number is only going to increase as conditions worsen. Accompanying famine, there will likely be an acute shortage of water as glaciers, which act as frozen reservoirs that feed major rivers and domestic water supplies, retreat. Much of the world's population is dependent on water from rivers that originate in the glaciers of the Tibetan Plateau. Some of the great unknowns, given the Earth is a complex system, are that there are numerous feedback processes that could produce a cascading effect over which we have no control, and could set us on the path to a hothouse Earth. As an example of how the feedbacks can lead to runaway global warming, we need only examine the effects of possible Arctic climate events as they loop back and lead to more and more atmospheric temperature rise. As if this isn't bad enough, there's another elephant in the room that makes climate change even more frightening, and that is liable to occur if we attempt to cease our current fossil fuel dependent industrial development. It is known as the aerosol masking effect, or global dimming. Generating energy from fossil fuels produces vast amounts of sulfates, which permeate the atmosphere and act like a screening umbrella, preventing much of the sun's radiation from reaching the land and sea. Were we to stop using fossil fuels, the subsequent lack of sulfates in the atmosphere would cause a substantial temperature increase. It is estimated that with a decrease of as little as 35% of industrial activity, there would be an increase in global warming of up to 1 degree Celsius within a couple of months. Such an event would make it very difficult for most biological systems to adjust. If this holds true, it seems we're damned if we do, and we're damned if we don't. Does this mean that life on Earth is doomed? The most prominent of what I refer to as doomsday climate prophets, Dr. Guy McPherson and the mysterious Sam Karana from the Arctic News blog, from both of whom much of the material herein has been sourced, predict that in the worst case scenario, the global temperature could rise by as much as 10 degrees Celsius from pre-industrial times, with a high probability that human life on Earth will become extinct within the next 10 years. Others, such as the distinguished Arctic and polar ice expert, Dr. Peter Wadhams, have a slightly more optimistic view. He does not hold with the near-term human extinction hypothesis, but does believe that unless we can come up with some way of removing carbon dioxide from the atmosphere, civilization as we know it is doomed. Who knows if it's too late? Only time will tell. One thing is for sure though, it's going to be a very rocky and probably very scary ride.
Hooray, 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 misery's on the way. There are bad times just around the corner. There are dark clouds hurtling through the sky. And it's no good whining about a silver lining, for we know from experience that they won't roll by. With a scowl and a frown, we'll keep our peckers down and prepare for depression and doom and dread. We're going to unpack our troubles from our old kit bag and wait until we drop down dead. There are bad times just around the corner.